In the 19th century, actually, it's interesting because I'm going to write yet one more book on this history. There was some fascinating work being done. Once you had microscopy and then different methods of staining tissues, microscopists, of which some physicians specialized in this, were able to begin to study fat cells and fat tissue and the origin of fat cells and fat tissues. And they would study it in fetuses, they would study it in frogs and tadpoles, and whether or not is this a separate tissue or adipocytes, just connective tissue that fill with fat, or are they separated? So that science starts to develop, but it's not seen as now. Obesity is not a major issue at the time. Some physicians are discussing it, but not researchers in any meaningful way. The second half of the 19th century, from the 1860s onward, is considered the beginning of the modern theory of nutrition, and it was based on the creation of a calorimeter by German scientists Voigt and Pettenkofer. The calorimeter you had always been able to measure the energy in foods by burning them in a calorimeter, but now Voigt and Pettenkofer created a calorimeter that you could put an animal or a human in and measure the energy expended. And virtually from 1869 or so through 1920, all of nutrition science was studying protein metabolism because you could measure protein with nitrogen in the urine. It depended on what you could measure. All science always depends on what you could measure. And the beginnings of some work on vitamins and energy expenditure, calorimetry. So calorimetry dominated the science of nutrition. If you read nutrition history books written in the 1930s, virtually every chapter is on calorimetry or protein metabolism. And so by the late 1890s, the only science, in effect, the only technology that the physicians had to make sense of obesity was these measurements of energy intake and energy expenditure.
And so this
And
has to,
meanwhile,
the use of a calorimeter like this, the invention of that device, the types of people thinking about that, a lot of people with a physics or engineering mindset, this is related to the origins of just thinking about obesity as a matter of being fundamentally energy in and energy out.
and because that's what they can measure. And meanwhile, energy metabolism, the laws of thermodynamics had emerged. Physicists were talking about energy. Energy was basically the currency by which you understood life. The difference between animate and inanimate objects was one had energy, the other did not. So by the early 1900s, actually first a Frenchman named Bouchard and then a German named von Noorden basically hypothesized that there's two types of obesity. This was always a general assumption. So there's obesity that could be explained by eating too much. Think Falstaff in Shakespeare. You had somebody who was overweight and they ate a lot. Therefore, you could explain that obesity is exogenous, caused by external factors, and the external factors were the amount of food they ate. But you always had people who suffered from obesity and did not seem to eat a lot. And these weren't the people that they came to talk about who might be lying about it. These were patients who came into these clinics and might stay for 6 months on a restricted diet and not lose weight. Or they might be kids whose parents checked them in because they had obesity and specific types of obesity, who the parents knew the kid wasn't eating a lot. They didn't have Snickers. Well, actually, in the US, they were just beginning to have Snickers bars, but they weren't kids who were hiding their candy wrappers under the bed that, we all thought about regarding the kids we knew who might suffer from obesity in college. So they knew that these people had very limited appetites. They knew that their obesity was resistant to caloric restriction for the most part. I mean, if you starve them, they would lose weight, but if you starve anyone, they'll lose weight, lean or obese. So they had to explain them, and the theory was they called it endogenous obesity. And the assumption pushed by this fellow von Noorden was that endogenous obesity was caused by a sort of metabolic defect that produced a relatively low metabolic rate. So eating was normal. Energy expenditure was abnormally low. That was a constitutional problem. And then this exogenous, endogenous theory ended up taking over the world. Ultimately, though, it was always blaming obesity either on too much intake or too little expenditure. Mm-hmm. And so on one level, von Noorden is the Newton or the Einstein of obesity research, except that he was wrong. And he was thinking only in terms of the technologies, the what could be measured at the time. Meanwhile, the science of endocrinology gets launched more or less also in 1869, but is this very
tenuous. It takes a very different track. There's a very different history and path there.
It takes till the 1920s before it really begins to blossom. And at this point already, that's when insulin is discovered and growth hormone is discovered and glucagon is discovered. There are very, very bright physicians thinking about endocrinology, but it's not metabolism and it's not nutrition. It's an entirely different field of research. And by the time physicians start evoking endocrinological explanations for obesity, they still think they're only evoking it first for this small proportion of cases that are endogenous, that can't be explained by how much the people eat. And then by the 1930s, they accept that actually the same hypothesis might hold for everybody, regardless of how much they eat. They need this constitutional predisposition to fatten easily. And that's an endocrine or neuroendocrine problem. And then World War II comes along and the whole theory vanishes. Like poof, the lingua franca. So the best medical science in the world, biomedicine, best science in the world is being done in Germany and Austria pre-World War II. That's all the great physicists of that generation. Almost all of them were Europeans and German and Austrians specifically. The Nazis party comes into power in 1933. Many of these were Jews. And by World War II, the medical community in Germany and Austria basically evaporates with the war. They have other things to worry about. And post-war, the lingua franca of medicine shifts from German to English. You no longer have to read the German journals.
So people literally just journals. They stopped working because they had to deal with the war. And then subsequent to the war, people just didn't know that history because they couldn't read it.
They did. Yeah, I would argue it's undeniable. I would love to get the historian to care enough to try and prove to me that I'm wrong. I mean, it's blindingly clear in the research. And then you also get this other phenomenon post-World War II. So the gravitational center of biomedical science moves from Germany and Austria, from Berlin and Leipzig and Vienna to the US, because the US has not been demolished by the war. And you get this whole field of young physicians and medical researchers who come out of the war. And then in the post-war, launch into research projects that the National Institutes of Health is now funding. And they read the American literature. They have zero desire, and for good reason, to not read the German literature. So if you imagine a whole world of physicists, in physics, we didn't have this problem because all these European physicists were embraced by the US and England and the Allies, because we had nuclear bombs to build and we were afraid the Germans would beat us to them. So the Manhattan Project, for instance, is full of German and Austrian Jews who are fighting the Nazis by building a nuclear bomb. So all this science and physics moves west with the war, but in medicine and public health, we wanted nothing to do with these people. And so, they flooded into the US. They weren't hired. Arguably the most thoughtful researcher in endocrinology and genetics ends up working at the Hospital of Medical Evangelists in Los Angeles, a Jew named Julius Bauer, who fled Austrian 38. The Ivy League institutions, which are dominating this research, want nothing to do with these people. And this theory evaporates. And meanwhile, these young doctors who flooded into the field just assume the obvious, which is that people get fat because they eat too much. And it seems so obvious that they never question it.
Mm-hmm, mm-hmm. And
And
so,
they have no.
yeah. And so the energy balance model is basically saying obesity, leanness, how much weight you put on, it's all about calories in versus calories out. If you're in positive energy balance, you're consuming more than you're burning, and therefore you will gain weight. And that the obesity epidemic and the patterns of obesity we've seen in the past decades, they are due to some combination of people eating more and more highly palatable, readily available food, and together with that, perhaps being more sedentary, moving around less. When we actually measure those things, when we actually measure things like active energy expenditure, basal metabolic rate, caloric intake, is that's what's actually happening?
Well, you can, well, so the positive energy balance. So the idea is, the law of thermodynamics. So delta E, the change in energy in a closed system, we won't get into the fact that humans aren't closed systems, but is equal to the energy in minus the energy out. Basically, what it's saying is energy is conserved. It's never created from nothing. So therefore, if the energy in a system increases, more energy has to enter than leave. And if the energy decreases, more energy has to have left than entered. There's an equal sign there. So it says delta E, the change in energy, is equal to intake minus expenditure. Mm-hmm. And that just says that the two sides of the equation are equivalent. So if you get fatter, you've taken in more energy. If you've gotten heavier, if your body mass has increased, and there are ways to get around this that probably have no physiological relevance, but for the most part, if your body mass increases, you will have taken in more energy than you expended. And then the energy balance model assumes causality there. There have been papers written in the past few years saying we don't do that. And we acknowledge that there is no causality, that this change in this equation is just telling you that the two sides of the equation are equivalent, not that one causes the other. But anytime you have someone believing that obesity, that the driver of obesity is increased food intake. So for instance, the theory with ultra-processed foods is that they are so, you use the phrase, highly palatable. They taste so damn good. They're addictive. We just can't say no to them. So we overeat. And as soon as you use a word like overeat, you are assuming that that's the cause of obesity. And this is now an energy balance model. It's wrong on this fundamental level, which is that the world is full of lean people who eat excessively. Mm-hmm. And don't get fat. I mean, mm-hmm. excessively. They eat enormous amounts of food, mm-hmm. And don't get fat.
Mm-hmm. There's a lot of people for which they're eating the same amount of calories, they're eating a similar diet, but one of them is packing on weight and one of them is not.
Yeah, and I mean, people always knew this. Again, one of the fascinating aspects of the research community, the research literature, like when you read the German literature, which you can now obtain and translate thanks to ChatGPT and other AI programs will do a remarkable job translating these. The researchers at the time, they knew this theory had problems. And in fact, they spent decades trying to demonstrate that that people with obesity who didn't eat a lot expended less energy than lean people. And they couldn't do it because people with obesity tended to depend. I mean, it's difficult. Who do you choose as your comparison? But people with obesity way more than lean people, so they tend to expend more because their bodies require more energy to fuel. So there were 20 years of research literature that basically said this whole idea of reduced energy expenditure is crazy because there's no way to measure it that it's meaningful. And you could always find two people of roughly the same size who have huge differences in energy expenditure. So what does the energy expenditure tell you about their obesity? And we have to find a different way to do it. And that's when a different theory was proposed, which is that fat tissue in some people was predisposed to get fat. They didn't know what was regulating this when it was first proposed in 1910, but all that was then worked out over the next 50 years. And that's when we get into the competing model. But this energy expenditure, I often want to ask people who believe in this idea that it's all about overeating. And again, in the energy balance models, they will say that explicitly. And by they, that's the proponents of these models, which are led by Kevin Hall, NIH, and John Speakman, a very influential obesity researcher who has joint appointments in Aberdeen, Scotland, and in China. And so the explanation now is it's a sort of, it affects energy intake, ultra processed foods and hyperpalatable foods affect energy intake on a subconscious or unconscious level. So you can't accuse people of eating too much, of having inadequate willpower, because all this is happening at a level beneath which willpower, but they're still eating too much. And the reason they're eating too much is because the foods available make it too difficult not to. But then you're left with the question, what's the difference between a lean person, invariably the people promoting these theories, and a person struggling with obesity? And the only answer I could find is that the lean person can resist overeating in this ultra processed food environment, and the obese person cannot. And now a theory that has been carefully phrased to avoid the implications of willpower starts to look a lot like a theory that's blaming willpower as the problem. It's a question I always want to ask these people is, I wanted to sit in a public square with some of these obesity researchers, and it gets very uncomfortable. But as somebody, with extreme obesity walks by, say to them, do you really think the problem with that person is in their brain and their inability to control their food intake or to eat in proper moderation? And this could be a 50-year-old woman, a 30-year-old man, a 12-year-old child, or is it simply possible that the problem is in their body? Their bodies are accumulating massive amounts of fat. And if they eat more than you and I do, and we don't know if they do or not, maybe that's because their bodies are trying so hard to store fat. That just like,
well, I think another key observation here that aligns with what you're saying is if you just look at childhood obesity, children, practically by definition, right, their brains haven't developed yet, so they haven't developed as much willpower as they will as adults. But we see skyrocketing rates of childhood obesity, and the children never used to. It's not like the children used to have more willpower. They've always been little kids that are running around like little kids.
But the problem with when you have an incorrect paradigm, you'll have an explanation. Well, any paradigm in theory gives you an explanation for all the major observations. For instance, one epidemiological association, right, is that bottle feeding, breastfeeding is associated with lower weights and better metabolic health in children, and bottle feeding is associated with higher weights and worsened metabolic health. So how do you explain that? Well, maybe the kids who bottle feed consume too much of the formula because the parents, and I mean, there are papers out there saying, look, the parents don't know when to stop. So they want the kid to finish the bottle, whether the kid's hungry or not. So they keep foisting the bottle on them, or with the breast, they can't tell if the breast is full or not. So they let the kid choose when to stop. So instead of suggesting the alternative hypothesis, well, people who bottle feed and people who breastfeed are different types of people. That's one possibility. If it's causal, maybe it's the macronutrient content of the breast milk versus the bottle milk. But now you need a theory other than calories to explain it. But if you believe that it's all about how much the kid eats, you can create an observation where, hey, these mothers just won't stop feeding the kids because they want the kid to finish the bottle on schedule, whether it's hungry or not. And then you train it to overeat. And now we have a child who has been trained from birth, in effect, to overconsume calories. It's
So
crazy.
one of the major models that is a competitor, a different model from the energy balance model, is what's often called the carbohydrate insulin model. And can you tell us a little bit about what that is and how it developed and when it developed?
Yeah, but can I ask if we can hold on for 1 second while I re-plug in my fan and my light? I
Oh,
unplugged
yeah,
the
yeah.
fan.
Yeah,
It's
go for it.
like 80 degrees here in Berkeley. My office is at the top of the house, and we don't own
Yeah.
air conditioning because we never needed it.
Ooh. Yeah. No, I'm in Seattle. Today's a pretty hot day in Seattle as well, but the
Yeah.
AC is on
Okay,
here.
hold on 1 sec.
All right, we're just taking a short break here while Gary tends to his setup. But obviously, Gary is a wealth of knowledge when it comes to not just the ongoing research world as it relates to obesity and diabetes, but the history of science here. And I definitely am a firm believer that understanding the history of ideas and the history of fields is very, very critical if you actually want to understand what we know, what we don't know, why certain ideas were developed, why certain models gain favor, sometimes despite the fact that they are lacking in key ways. And so, I'm sort of a history of science nerd and have a lot of appreciation for people who really understand what the ideas are and where they came from and how they developed.
Yeah. How's that?
Okay. Yeah. Good to go. Yeah. So
Fan isn't an issue. Okay.
the carb insulin model. What is that, and how did it come onto the scene?
Uh, okay, so the carbohydrate insulin, sort of the dietary implications, or the dietary implications of the bigger theory, which is that obesity isn't an energy balance disorder; it's a fuel partitioning disorder. It's not about how much you eat; it's about what your body does with what it eats. This was the competing hypothesis in Germany and Austria. It was first suggested in 1910, basically that some people are predisposed to store calories as fat. Their body preferentially stores calories as fat, and it doesn't have to store a lot. So if you store, let's say you eat 2,500 calories a day, which wouldn't be unusual for somebody my size at least, and your body stores 0.1% of that to excess every day. So 25 extra calories go into your fat tissue every day that don't come out. Is that right? Is that 0.1% of 1%? 25 is
Yeah,
1% of,
25 would
yeah,
be
that's right,
yeah.
1%. Anyway, it's just that much, those 25 calories a day stored as fat, as excess fat, will accumulate to 2.5 pounds of fat a year, or 25
Mm-hmm.
pounds of excess fat a decade.
Mm-hmm.
So a tiny amount of excess fat storage could explain even massive obesity. Is not
Yeah.
that if somebody gains
Yeah.
100 excess pounds in 20 years, so they weigh 300 pounds when they should weigh 200 pounds, that 100 excess pounds is basically 100 calories per day that their fat cells stored that the lean version of them would not have stored. And that could easily be a neuroendocrine. So the nervous system regulates fat storage, and hormones regulate fat storage, and there's a balance between them. Nerves stimulate what's called lipolysis, which is a mobilization of fat from fat cells, and the hormone insulin primarily inhibits lipolysis. So higher your insulin levels, the more fat you store. Again, this hypothesis was first suggested in 1910 in Germany by a fellow named von Bergmann, famous physician. And then the war hit, World War I hit, obesity research pretty much shut down. And beginning around 1920, it kicks up again. They start discussing all the failures with these energy expenditure experiments. And von Bergmann's idea gets more and more credibility. And then this Austrian endocrinologist named Julius Bauer takes it up and runs with it. And by the 1930s, it's pretty much accepted in Germany and Austria as the viable hypothesis, which is that obesity is basically caused by this preferential storage of calories into fat, uh, phenomena that's regulated by the endocrine system, hormones, and the nervous system. And people get fat because there's an imbalance in these systems, and you end up, in effect, post World War II with people who are still studying fat metabolism, linking all this to insulin as the dominant hormone. And insulin is the hormone that dominates fat storage. So we secrete insulin primarily in response to the carbohydrate content of our diet. There are other fields of science that are implicating sugar and other fields of medicine implicating sugar and refined carbs and obesity and diabetes and heart disease epidemics in countries undergoing nutrition transitions. And by the 1960s, you have the low carb or ketogenic diet induces weight loss without ever telling people they have to eat less. Whether they do or not is a separate issue.